Hey guys, I'm Amber. I'm going to be talking about magnets and ferromagnets and electromagnets. And I've had a lot of fun studying about them, so I'm excited to teach you guys. But first to start out, I just want to talk about magnets in general. And like most people know, all magnets have two poles, a north and a south pole. So you can see the north pole and then the south pole. And these poles, if they're the same, will repel, like is shown here. So if you have a north lining up with a north, those are going to push apart. And I think we've all felt that when we try and put two magnets together and we put together the same poles, they're going to push apart. And then the unlikes are going to attract, as shown in this part of the picture. And then if you guys break a magnet in half, you don't get just one like south pole. Like if you break a south pole, it won't just stay south, but it will actually become its own new magnet. So breaking one will give you two, breaking two will give you four, and so on, all the way down to the tiniest atom. Even magnetic atoms act like tiny little magnets, so they even have north and south poles, like you can see in this picture. So first I want to start out talking about ferromagnets. And ferromagnets are kind of your everyday magnets. They are made from metals that have magnetic properties. The most common one's iron, which is why it's called a ferromagnet, because ferrum in Latin means iron. So these ferromagnetic materials all have strong magnetic effects, and they can respond to magnets, and they can also be magnetized themselves. And we'll talk about that in a second. But their ferromagnetic materials have microscopic scales and also macroscopic. So on the microscopic scale, it means that all the little atoms in the ferromagnetic materials actually act like small magnets, and they have all their magnets like lined up together. And then on the macroscopic scale, it's when you put a bunch of those atoms together into domains, and they can be arranged in these domains, but as you can see, like they go off in different directions. So we're gonna see in the next slide that these domains can actually be arranged into a permanent magnet by lining up all these in the same way. So once these are all lined, they'll be a magnet, whereas right now they're kind of just going off in every direction. So you can make permanent magnets out of these ferromagnets, or these ferromagnetic materials. So they can align themselves. This is kind of the same as the last one, but they'll all line up to the same with the north and the south pointing the same direction, which makes a permanent magnet. So if they're going to be induced by putting a magnet. So if I put a magnet by this ferromagnetic material, it'll point all the norths towards that. Say it's a south magnet, it'll point all the norths towards it. And then if you heat that material and then cool it, or tap it in the presence of other magnets, like it says, then it will actually make a permanent magnet that will, you can stick on your fridge or whatever. So as you can see, this is the ferromagnetic material. It's iron, and then it's going to induce that magnetism, and then once it's heated or tapped or whatever, now it has this permanent magnet. And as we learned so well in Physics 106, the source of all magnetism is current, which leads us into the next type of magnet I wanted to talk about, which is electromagnets. And these magnets run on electricity. So it's actually an electric current that makes these magnetic fields and creates this electromagnet. So most of the time you'll have this metal core, so iron again, this metal core, and then have a wire wrapped around it, and a current is passed through that wire, which creates that electromagnet. And as we can see, and we learned with the right-hand rule, the second right-hand rule, you can find the way that that current is moving and see which way the magnetic field is pointing depending on the direction and everything with the right-hand rule. So, and the thing that's cool about these, that's a little different from the ferromagnets, is that the strength can be changed because you can determine how much current you want to send through it, and it can be reversed because you can change the way that the electrons flow. So that's pretty cool about electromagnets. So a few examples of both. Like I said, ferromagnets are kind of your general magnets that you'd stick on your fridge, kind of the magnets you see every day, north-south pole, everything. And then obviously electromagnets also have that north-south pole. That's something that's similar between them, but it is induced by that current. So these, you can see a lot of real-world applications. You have your MRI machine right here is actually a big electromagnet. So that's another cool fact. And then there's motors that are made out of electromagnets, and also generators, loudspeakers, things like that. And then a lot of these magnetic separations, so you can actually see this would be the metal core, and then running through that would be a coil, which actually, pulls up all of these metals, and so you can actually, separate. These big metal separating machines are using electromagnets. So for the rest of my video, I took a chemistry class, a lab, that I really liked, and we actually made ferrofluid. So that relates to ferromagnets because it's kind of like a ferromagnet and a fluid mixed together, and I'll explain that a little bit. But I want to do an experiment on making a ferrofluid because we did this in my chemistry class and I really liked it. So I wanted to redo it just to kind of, add a little something to the video and show you guys how these ferromagnets work, or I guess these ferrofluids. But so these ferrofluids, it's a combination of a ferromagnet and a fluid. So these ferromagnets have these strong little magnets in them that display this permanent magnetism. So if you put that with a liquid, then you can get a ferrofluid. And it's, like you can see in this picture, it actually creates these spikes, which is really cool. But the little magnetic field turns these particles into tiny magnets, like we talked about before. And then they actually can move around. So say I held like a magnet up right here, these spikes would actually form up to the magnet. And I'll show you guys that later. But the magnetic fields, along with the gravity and the surface tension, allow these particles to make these spikes. So yeah, I don't have time right now. Obviously, I'm still working on the experiment, so I'm just posting this video for now with the, I guess, learning side of it. But once I finish the experiment, I'm going to add it to this video at the end, because I've only done part of the experiment. Anyways, I hope you guys enjoyed learning about ferromagnets and electromagnets. They are all around us, and they, ranging from, our MRI machines and helping us stay healthy, and also our just normal magnets that stick on our fridge, and even down to the little buckyballs that little kids play with. So they're really in our everyday lives, and they're so important. And yeah.